So how do things compose across domains? Hi, my name is Eric Normand, and these are my thoughts on functional programming. So a couple episodes ago, maybe 4 episodes ago, I talked about how things compose. And just to review, when two actions compose, it creates a new action. You can compose either in sequence or in parallel. Calculations compose and they create a new calculation. It's basically function composition as it's normally defined. But I like to be a little looser and say, well, you can actually have a calculation that the output of that calculation goes into any of the arguments, not just the first argument of the next function. And then data, two pieces of data can combine, can compose, and that really depends on the data structure, but stuff can compose into a tuple or into a sequence or into a hash map with the keys and values being the bits of data. And what I realized was I didn't talk about how things composed across domains. So what happens if you have an action and you compose it with a calculation? So let's go over that now. We'll have to review the 3 domains and what they mean. So actions, real quickly, there's a rule of thumb. It's called time or times. So does it depend on the time it is called or how many times it is called? If either of those is true, then it is an action. So, sending an email twice is different from sending it once, right? So calling that twice has a different effect. Calculations don't depend on the time, but they can calculate a value based on the arguments, and they're opaque, meaning you don't know what it's going to do until you call it, until you run that. And then finally, data is totally transparent, self-describing, self-identical, meaning it is what it is, and you can interpret it in multiple ways. It doesn't run, it's totally inert. Okay, so what happens when you compose an action with a calculation? This is something easy, like you want to uppercase a string. That's totally a calculation because it doesn't matter when you call it. It's always going to give you the same answer. And so you're doing uppercase string, and then you're going to print it out. Now, printing it out is obviously an action, because if you print it out twice, that's different from printing once or 0 times. And so we're doing a calculation and then an action, and we want to compose those up into something else that does both of those things. Now, here's the question. What is that thing that's like print uppercase? Well, it obviously also depends on the time or times, because it's still printing. And so that thing that you compose the 2 into is an action. And you'll see if you just by thinking about a lot of examples, anytime you have an action and you compose it with anything else, it's going to be an action, because you can't lose that dependence on time. So we see that anything composed with an action, anything meaning any calculation or any data composed with an action, is going to lead to another action. Now, similarly, we could ask, what happens if we compose a calculation with data? So this is called a closure normally, where you have some data that's in the scope of the function, and so now this is part of that function for good. And it's going to influence the calculation, but of course it can't change, so it's still timeless. It's still a calculation. But it's totally opaque, just like other calculations. So it's not self-describing. It's hard to define equals for it. Like data is very easy to describe equals for. And so you have data plus calculation is going to give you a new calculation. All right. So if you arrange things in that order, the order that things kind of progress to, meaning like you look at data plus data is data, but then data plus calculation moves up to this other level. And then calculation plus action, that moves up to the actions. So we have this kind of migration. Maybe we should turn it up the other way. So stuff is going down. It tends to move down. From data, it moves to calculation. And then from calculation, it moves down to action. And this is just a natural tendency because there's no way to remove the time except by effort. Like you actually have to change your code and refactor stuff to extract out the parts that aren't actions into calculations. Whereas it's so easy to just put two things together and now you have more actions in your code. So there's this natural tendency in our code bases, even a functional language's code base, even something strict like Haskell, there's a tendency for things to slip down into actions. Also, stuff in data will slip down into calculations. It's just a natural tendency because we like to compose things and things are just going to move down that way. And so one of the things that we have to do as programmers to remain vigilant to is that we always want to counteract that natural tendency by pushing stuff back up this ladder into data. And so that explains one reason why functional programmers are so reticent to use actions is because they start to infect everything. And it's much better if you could avoid that to begin with. All right, thank you. My name is Eric Normand. I'd love to discuss this further. You can reach me on Twitter. I'm at Eric Normand with a D. And you can also email me at eric@lispcast.com. Awesome. See you later.